I'm going to pause my video because of the web bandwidth. So we will primarily
Sure,
focus on the PowerPoint slide first.
sure, sure.
First of all, I just want to confirm, are you able to see the slide?
Yes, we are.
Okay, that's great. First of all, thank you very much to Mohsen and Pakistan Agile Education community for having me here to basically present about Internet of Things. Uh, Assalamu alaikum and a good evening to everyone. My name is Usman, and uh, let me just give a brief introduction about myself. Um, I've been working in software industry for 19 years, and out of those 19 years, 12 years have been primarily in IoT industry, from research and development to engineering, and now more on deployment aspect of it. As Mohsen also mentioned earlier, currently I'm working in Australia. I'm working for Monash University and Monash City Council, where my role is solution architect and project manager for designing, developing, and deploying smart city project. And besides that, I'm also a committee member for smart cities in Australian technical standards, where we basically adopt and propose technical standards for smart city implementation in Australia, as well as I'm also a technical committee member of 5G in Australia. And then before joining this smart city project, I was working for Intel Corporation Internet of Things Group. As most of us know about Intel, that they develop most of the chips for PC, laptop, and so on and so forth. But there is a big group which is primarily leading the embedded business. And within the embedded business, they call it IoT group, which is roughly generating $3 to $4 billion annually, whereas the PC business generates roughly around $30 billion annually. So in Intel, I basically was one of the architects for application as well as for connectivity. And I did work on a different silicon as well as software project for Intel related to enabling smart factories, automotive industry, smart home, smart cities, and so on and so forth. I was also part of the standardization organizations, even though I was based in Malaysia, but my work was primarily dealing with US, Germany, and the rest of the world. So from that context, I worked for Zigbee Alliance as a license for Intel globally. I worked as a license for Intel in Internet Industrial Consortium, which is IIC. There is another one, which is OPC. This is a primary standardization organization for factory automation, and a couple of other stuff where Intel basically asked me to work for and sort out the stuff for them. I have been advisor for Malaysian government related to communication standards related to IoT again. I have a technical standard which is adopted by Malaysian government. Then there are a couple of other stuff which I've done for government, for the universities and R&D organization within IoT space. Roughly 25 patents I have in this area related to IoT, artificial intelligence and security, and 24 publications, and also contribute a couple of technical standards. So the reason I'm here is basically having this experience in IoT industry for so many years. Basically, me and Mohsen talk about it, that how can we help our community in Pakistan, and I can bring forward what's going on in the world, and then I can help the community to move forward and contribute at the global level. So are we good so far?
Yes, Usman, we are. So we should start now.
Sure.
Thank you.
So basically the key agenda for this webinar would be we will define IoT. We will see what are the standard definition for Internet of Things, and what are the key elements which creates the IoT. Then we look at end-to-end solution. which are basically composed of IoT as a fundamental building block. Then we look at some specialized requirements which are different than most of the software industry which Pakistan is working on. As an example, when we talk about web applications, we talk about business applications, there are certain requirements which we need to fulfill. In the case of IoT, there are very different requirements. So we will touch those areas. Then I will give a holistic view of the standardization aspect of the IoT, and we will talk about IoT solutions with a short use case discussion. And in the end, we will have a general discussion about IoT, whatever the questions that you guys have. And primarily, I want to say that as I go slide by slide, basically you can jump in and you can ask me questions if you have, and we can have a general open discussion about the technology itself. So while defining Internet of Things, it's better to understand one important thing, which is Internet itself. So as we know that Internet is a global computer network, which consists of different servers and different computing machines connected or interconnected globally to provide a different type of services. And it is basically achieved using a standardized communication protocol. So internet is basically this. But when we talk about Internet of Things, generally people get a miscommunication or assumption that we take the things and we connect with the internet. It means the Internet of Things, but it is not. So if we refer to two sources, one is International Telecommunication Union, which is under the United Nations. They develop different type of technical standards and codes and so on and so forth. And second one is Wikipedia. I referred here for your illustration. Primarily, Internet of Thing itself is is basically a network of physical objects, network of cyber physical objects, which are connected through a network, and they can be managed, they can be securely communicate with each other, as well as to the servers and the other entities over the internet. And they primarily provide a source of data. Either that data can be used for making decisions, or it can also be used for taking actions. So in a nutshell, Internet of Things is a network of physical objects which are connected with each other. Each of the object has sensors, it could have actuators, and the primary thing is that they will connect and communicate with each other, and that is the internet side of the picture. So these IoT itself is an evolution from embedded systems. When we talk about embedded systems, embedded computing systems, embedded computing systems have been used as an example, in cars. It has been used in factories. It has been used in many different type of use cases for a long time. The only difference there was that most of them are proprietary, and they don't really communicate to the outside world. So there is a certain loop that they work within it, and they provide a certain type of application. So while looking at the IoT itself, I would say that there are five key elements here, which is baseline is a hardware or a computing. The baseline is the computing or a hardware. And excuse me, could you please mute? I think somebody
Yes,
is talking.
sorry, Usman, I have muted them. Please continue.
Sure, thank you. Thank you. So primarily, IoT consists of these key elements, which are computing, connectivity, security, manageability, and once we get the data, it basically we work on the insights to do data analytics and machine learning. So the baseline, which from embedded system comes, is the hardware or the computing aspect, and that computing aspect actually connects to machine. It may be a motor, it could be some type of temperature sensor or a humidity sensor or a factory floor belt and so on and so forth. But the rest of the things are especially designed for embedded system purposes. So let me go forward to get a better idea about it. So let's say when we talk about hardware. So in the case of hardware, we have computing itself, we have sensors, we have actuators, and so on and so forth. And generally speaking about Internet of Things, we have these type of different type of boards, computing boards, which has we can do input of sensing or input of sensors. Like these are different type of sensors on the site. As an example, these are IR sensors and so on and so forth. These could be connected using some type of digital or analog input output ports on this computing hardware. Then we basically get a connectivity aspect of IoT, which is there are different type of connectivity technologies. Generally speaking, when we use our phones or we use laptops, we normally talk about Wi-Fi or we talk about Bluetooth, and sometimes we also talk about cellular technology like 4G or 3G. In the case of Internet of Things, we have actually different sets of connectivity technologies, specially designed for it. As an example, LoRaWAN is one of the wide area network technology. It's a low power wide area network technology widely used for application in smart cities. Whereas Zigbee is another wireless technology which is being used for smart homes and sometimes also for smart energy use cases. I also have it here, MQTT. MQTT is a high level connectivity protocol, which is generally used for publishing and subscribing of the data. And then we basically talk about, or we look at the manageability aspect of it, because as you know, when we are talking about IoT, it is going to be not few, but rather going to be hundreds and thousands of devices. Now, on hundreds and thousands of devices, how are we going to manage it? I mean, how are we going to, for example, from network aspect of it, how will it be managed? If we talk about the software aspect, like I believe, when you use Windows, you have daily or you have, periodically you get the Windows updates. So in the case of these computing devices, which are running different type of operating systems or firmwares, they also need to be updated. So how are we going to manage to do over-the-air updates on those IoT devices when there are going to be thousands or millions or billions of them eventually? And similarly, there are different aspects of manageability, which comes from devices to software to network. Then, if we talk about we're going to send the data, we're going to connect to the network, we're going to manage it, it has to be secure, because if it's not secure, anything could happen. As an example, 2 or 3 years ago, there was a smart car which was basically hacked by someone, and it was eventually having a severe problem of having an accident. It was a very basically big news back in, I think, 2018-19 timeframe. So just imagine if you're going to have your sensors in the home and some hacker can control it over the network, then it's going to be havoc for everyone. Similarly for medical domain and the smart cities as well. And lastly, once we securely send the data to a backend system, then there's tons of software which is available, open source software, closed software by different vendors as well, that can be used for data analytics as well as for building different type of machine learning and deep learning models. Did you have any question on this slide? So far so good.
Yeah, not so far. In case if anyone has any question, please use the raise hand option, or you can also choose the chat.
So when we talk about Internet of Things end-to-end solutions, generally speaking, it actually consists of this type of pattern where on the left side we have IoT edge devices. It could be a parking sensor. It could be a sensor which is attached to a pipe to detect the leaking. It can be a smart bulb, smart camera, smart traffic lights, and so on and so forth, which connects over a specialized network. As an example, it could be LoRaWAN, it could be Zigbee, and so on and so forth. And it connects to some type of a gateway. So why we need gateway here? Because when we talk about Wi-Fi and Bluetooth, directly communicate Zigbee or LoRaWAN and these type of technologies, they don't have direct access to internet because they are not internet protocol based uh, connectivity. That makes a lot of differences in terms of software options, and each of them may require a different application model to basically develop application. So some of them you may have to write in C language, others you may have to use the assembly language or something other type of model. For example, Contiki has a C-like program structure, but it is not a C language. Now, then when these IoT devices communicate to the gateway, as I mentioned earlier, there could be Zigbee, LoRa, or there could be like EtherCAT, which is specialized connectivity technology for factories, and that connect with some type of powerful or mid-power computing solution. And that computing solution could have some type of Linux version or real-time operating system version or Windows. Generally, when we talk about industrial PCs, they are having a specialized version of hardware which runs Windows. And then there are other different type of operating system also within this entity beside Linux. Sometimes there are hypervisor used for these type of edge devices where if let's say a customer wants to use like Siemens or ABB, they want to use this type of device for multiple type of operating system at the same time to handle different type of edge devices, then it will be easier rather for consolidation. And then when we talk about server side, we have basically again Windows and Linux and different type of cloud service providers such as AWS, Microsoft Azure, Google has their own platform. And you may have noticed here that I have put cellular, which connects from edge nodes to the server. These are the nodes which are primarily running with a machine-to-machine or a cellular SIM cards. It's like, you may have noticed about utility meters. Utility meters sometimes having 4G or 3G SIM cards, which directly send the data to the backend servers. And then once we have different type of applications running on the server side, which, as you know, there are a lot of stuff that can be done there from microservices to uh, so on and so forth. Then the end user uses some type of analytical dashboards or a web or mobile applications to basically get the data out of it, the data which is insightful for the customers. So you may get a holistic view that it is quite challenging to make an end-to-end solution for Internet of Things, because when we talk generally about the business applications, or we talk about web applications and so on and so forth, we only have the server and then we have different type of clients, which basically interact with the server over the internet. But and in that case, we have a data which is coming out from the databases of the server. But in the case of end-to-end IoT solution, the data is actually coming out from the edge nodes, and it is basically collected on the server and having probably different type of formats or encoding, which has to be convert it into a format which is representable into a, let's say, MySQL DB. So I can give a couple of examples that for the end-to-end solution, we could have smart parking, where we have smart parking sensors at the edge nodes. And, we have basically the gateway and the server doing the end-to-end solution for parking, street lights, manufacturing, home, and so on and so forth. So what is this opportunity? We're actually looking at a huge opportunity of 50 billion devices, which is going to be deployed for different type of segments. It is an industrial segment, home segment, smart city segment, and so on and so forth. And in order to achieve it, just imagine that how many type of devices that need to be connected to the physical infrastructure. And then how are we going to connect immediately through a gateway or a edge computing device to backend systems? There are basically reports which are telling that we're going to have very soon around 44 zettabytes of data which need to be handled on the server side or cloud side. And 1 zettabyte is approximately a billion terabyte. So just imagine how much data is going to generate and how are we going to do a management of data and eventually take out the insight and do analytics out of it. As I mentioned earlier
Usman,
that,
sorry to interrupt you. There is a question from Salman Nemat in the previous slide, the previous one. Which protocol is more suitable for scalability in terms of nodes?
well, basically it all depends on different use cases. When I go further, you will get better idea because as an example, when we talk about uh, the IoT requirements for a certain use case, we have a requirement as an example for battery operated IoT devices. Now, in the case of battery operated devices, if we want to have a short communication or we want to have a long communication, if we want to have a long communication and the data which need to be sent over, as an example, once a day or twice a day, then we will use LoRaWAN. If let's say we want to do a communication which is also maybe once or twice a day, but it's a short distance, and it's also operated using a battery, we will go for ZigBee. So it depends on the context of where we are using. So I think I'll give a better idea once we go further in the next slides.
Sure, thank you, Usman.
No problem. When we talk about a general PC or a general computing solution, we know that we have a very specific segment of customers. As an example, from the context of computing, we have a customer segment which is for, that's a laptop. There's a customer segment for servers. There's a customer segment for PC and mobiles. So there are these type of, you basically create those type of markets for these customers. So like say, we talk about Dell, we talk about Acer, and Apple, and so on and so forth. These are companies which are making these different computing solutions for customers. But in the case of IoT, we basically have a broad spectrum of customers. How come? Let's say when we look at a factory, the factory computers need to run in an environment which is very harsh. It is going to be, let's say, 120 degrees Celsius to 150 degrees Celsius in some cases. There is a lot of vibration, there is a lot of noise. So it needs to be prone to those type of, interruptions. And still need to work 24 by 7 to do factory floor computing solutions. Similarly, when we talk about IoT solutions which are going to use in a smart city, where let's say if you have a device outdoor on a pole, and it needs to sustain during the time when we have a rain, we have a full bright 45 degrees Celsius like in Lahore, and probably like minus 10 degrees Celsius when it's in a very cold hilly area. So there is a broad spectrum of requirements which need to be met by not only from hardware perspective, but also from software, because software could also crash. Then if I go further from the long life perspective, If let's say the device is connected to a main power supply, I think it's quite easier to operate. But once when you talk about having batteries into the IoT devices, then the question comes in: how often do you want to send, and then when do you want the device to be in a sleeping mode? How often they need to wake up and send the data and so on and so forth. So then we basically have to look at different type of sub use cases for operating and deploying those IoT devices. Similarly, when we look at, as I mentioned earlier, about power, which basically consists of either using different type of batteries, different type of power connection. So it varies the actual deployment of the IoT devices. Then um, operating systems, like in the case of PC market or a laptop market or a phone market, we know we have Android, we have a iOS, we have a Linux, we have a Windows. But unfortunately, in the case of IoT, we have actually hundreds of operating systems, which make it very complicated. Why we need to have a hundred of operating system? Because there are different type of chips. It's not using normal Intel PC chips, or it's not using AMD chips. Generally speaking, we have ARM chips, which are microcontrollers and also application chips, which basically required a certain type of drivers which need to be developed. So it's actually quite complicated landscape for operating system. But those operating systems are very much close to the hardware, and they operate very optimal for the hardware. Then a requirement for the bandwidth and latency, which means that let's say we have a smart camera deployed in, let's say, Mall Road in Lahore, or any major area in Lahore or other part of Pakistan. Just imagine that if a single camera is generating 1 megabyte or 1 megabit of bandwidth, and if we have hundreds of cameras, thousands of cameras, how much data they will be generating, and how often they will be sending. So that also needs to be managed from the device's perspective, because they need to encode and decode. And then network aspect of it, because if it's a fiber optic, it's a one part of the solution. If it's going to be a 4G or a 3G, it's going to be another challenge, because you pay for the data, and then there is also a congestion problem, a wireless aspect of it. Lastly, it's a function safety, which I explained a bit earlier. Functional safety means if you put a computer in a car, as an example, you're listening to your music, or a computer which is calculating your fuel injection in your car. Just imagine you're driving at 110 kilometer per hour, and all of a sudden, if it crashes, just like the way when you have a blue screen in Windows, what would happen? So in this case, there must be a functional safety feature which elegantly control the crash if it happened. First of all, it shouldn't happen, because if it happened, it's going to be a big problem. Another example was one of the space shuttle program back in 80s. I'm not sure you have heard about it, but there was a defect in writing an if condition. Rather than putting double equal to sign for checking the condition, the programmer put one equal to sign. And what happened was, when basically space shuttle launches, after a few seconds, it actually crashed, because that part of the code crashes. So again, the software system, the hardware system that we need to build, need to fulfill very harsh requirements here. So uh, I think you probably start getting some idea about IoT here, that IoT actually enables those use cases which are not generally business or web application. It is a fundamental building block for enabling a smart home market, smart factory market, smart cities market, smart agriculture market, and so on and so forth. Now, if we look at from the standards perspective, because when we talk about a PC market or web applications or business applications, there are tons of standards there as well. Some of the standards are coming out from the standards like uh, IETF came out with standard for, as an example, IPv4, IPv6, HTTP, and so on and so forth. Then W3C came out with a standard for World Wide Web. And, then similarly, when we talk about HTML, we talk about CSS, and so on and so forth. There are a lot of, groups, or working group, which create those standard way of creating those computing solutions. Now, in the case of IoT, it's a different game, because when we talk about market segment for factories or industrial, market segment for automotive, government, communication, consumers, there are a lot of different companies or alliances or organizations which are working on it. In this slide, what I've tried to show here is there are different aspects of standard which are covered. As an example, when we talk about connectivity, we talk about identity and privacy, we talk about manageability. There are different alliances which are covering it. There is no one alliance which is covering everything. So, like previously, when I was asked that, if let's say we talk about which connectivity option will be good uh, for probably for most of the solution, there is not a single answer. We actually have to look at again the requirement. As an example, we are looking at deploying a solution for a smart city or a factory or a smart home, and all of them will have a different level of detail that we have to look at and then decide. And that is part of the IoT architect position, which or role I was having in Intel to decide, different type of end solution, what type of technology will be useful for us to provide to a customer. Like here, just to give an idea, Zigbee is a alliance which provide specifications for smart home market. Similarly, Google came out with the Thread. You may have heard about a couple of smart solution coming out from Google. They bought a smart thermostat company, which is basically based on this alliance. Similarly, when we talk about a smart metering infrastructure, Visan is one of the alliance which is providing it. Then, related to factories related standards, Industry 4.0, um, Industry 4.0 is coming out from Germany, which basically look at how the next generation or in next industrial revolution would have those features or those type of technologies which can build the next factories. Similarly, China is coming out with their own 2025 agenda, having a different type of standards, which basically make their own solution for Huawei and ZTE and so on and so forth. So this is a very interesting picture for me, because what it tells is that we have actually different type of IoT standards, and it is not possible to achieve a single standard to fulfill all the use cases. And while looking at the market dynamics and technical aspect of it, as well as business opportunities. Similarly, there is definitely going to be a very big problem of interoperability of standards. And it basically different companies and different alliances and different organizations are already stating it. But the key thing there is that eventually it will be all converged. I have seen personally while I was working as a liaison of Intel Corporation in Zigbee, that there are different companies or different alliances like IPSO, Zigbee, and there are a couple of more there, which basically work on making one converge standards so they can interoperate together. What it means is, for example, if somebody buy a Philips bulb and someone else buy a button which need to communicate with the bulb to turn it on, it could work from Zigbee, it could work from Thread, it could work from OCF and so on and so forth, rather than all of them having their different ecosystems. So this picture on the left shows a traffic jam from Beijing, Hong Kong, Macau expressway. This is 50 lane 50 lane road, and it converged to 20 lane at this toll plaza. So, and then, it basically make its way, and it will be the similar case, I believe, also for IoT. So now, why IoT is very important while moving forward for next generation applications? Because it actually provides us a meaning, or it provides us a way for us to acquire data from a cyber physical systems. What it means is, as an example, if we talk about factory floor, we have different type of factory machinery there. And that machinery basically, when we turn on, it has a very specific type of vibration. So if we start collecting this vibration data and we build a machine learning model which tells that this the normal vibration of a machine should be, let's say, A. And if, let's say, it goes beyond the A, which means there might be some problem within a machine, or there could be a problem eventually coming out from this machine. So we could do a predictive analytics, which is one of the biggest use cases for IoT. Secondly, we can build, context-aware real-time application, such as when you talk about smart cameras deployed in a smart city uh, use case, you could actually find people which are moving from one direction to another direction uh, to basically reaching to their destination. I think one of the good examples is from China. The Chinese government is monitoring when people basically move from their trains to offices. They can actually track anyone within the China within 30 to 45 minutes range. So basically, you gave the picture. There's a way for them to do, to find within the whole, millions of cameras infrastructure. And lastly, this data basically help us to do optimization. I can give one example from the project which I've been working recently. We basically we get a problem from a Munar City Council that they have basically different uh, parking areas within the city. We deploy 700 parking bays. We have basically deployed 700 LoRaWAN sensors integrated into the road. And then we basically look at the data to see what type of pattern it can show us. And one thing which we noticed from a multi-story car park, that there are people basically who park mostly on the ground floor, and then on the first floor, and then the second floor. And the city council basically wants to basically make it more optimal parking scheduling, because currently they have the pricing scheme is a flat. Whoever parked the car for 1 hour will be this price, 2 hour will be this price, and so on and so forth. So they want to basically motivate people to park on the second floor, so it will be more cheaper for them to basically uh, allocate parking there, and also for people to pay less if, let's say, they're going to be there for more than 2 to 3 hours. And they managed to make this type of business model based on the data that we have provided them, whereby the first floor will be having a different pricing range, second and third will be having a different pricing range, because we can tell them based on a couple of months of data that what is the pattern of users. So now, when we look at the consideration for building IoT solutions, we basically have to see what could be the hardware or computational requirements. As an example, if the solution is very simple, just have to read a temperature sensor, humidity sensor, we may need a 8-bit microcontroller. We may need to look at how many sensors we need to attach, so we have to consider about how many input-output ports that board will have. Similarly, if, let's say, we want to do a smart camera type of solution, then there must be some type of accelerator which needs to be added on that computing solution, which basically impact directly on the power usage. Connectivity. We need to look at requirements such as what will be the throughput requirement for us? What will be the latency requirement? Throughput requirement could be let's say if we're gonna send the data every second, or we're gonna send the data which is going to be every 1 hour or 1 day. I can give one example of bin sensors that we are using in the Monash Smart City project. We configured them to send data only once a day. But if let's say that the threshold value goes more than 90% of the fullness level of a bin, then it will automatically trigger another message. So generally speaking, we may have only one or two message per day coming out from the bin sensor. And in the LoRaWAN case, if you look at the spec, it actually provides 150 kilobits of throughput. So for 150 kilobits of throughput, we basically managed to get what we need to do uh, in that network technology. But in return, the great thing that we get is 4 to 5 years of battery. So the parking sensor that we put there, or the bin sensor we have put there, we know we only have to change the batteries after probably 3 to 5 years. Whereas we have put that smart cameras and lidars. Lidars are specialized cameras, I would say. They actually generate 1 gigabyte of data per minute. So the throughput requirement will be very different. So we have to use a different type of connectivity technology. And in that case, we are also using a specialized computer only on the edge, which can compute and take out the data, which is relevant for us, and then transmit over the internet to the backend system. Like LoRaWAN also provides a roughly 15-kilometer range of coverage if you are using in a rural area, whereas in a city environment, it provides roughly 1 kilometer to 2 kilometer range. So these are different aspects that we have to look at while deciding about IoT solutions. Software, again, operating system is one, programming languages such as C, Python is another one. Open source part of it is another aspect, because let's say you're building a solution, you want to do a quick solution, probably you can, git pull one of the open source project and customize according to your needs. Security is very important. Uh, there are aspects like authentication, there are aspects like cryptography, for example. Do you want to use SHA, you want to use AES cryptography to securely, you know, excuse me, you're going to basically encrypt your packets and send it over the network. And then management aspect of it, because just imagine if you're going to manage thousands of devices in terms of their devices itself, which is a physical aspect of it, because, for example, when you deploy your parking sensors, you also need to tag them or give an identification number. You also have to look at their software versioning. You have to look at their keys, because when you're going to put the security keys, you also have to manage in one way or another way. Similarly, when we're going to do over-the-air updates, you have to look at those aspects as well. That when will be the right time for you to, update. Like in our case, we mostly look at 12 o'clock at night until 3 a.m. in the morning. So that's a time when we are not sending any application data. We just look at how we can update those IoT devices. Power, which means if it's going to be battery, how much power, how many microampere that device is going to consume, and if it's going to be main supply, how are we going to pull that power cable to that IoT device? Like when we deploy the smart poles, smart pole definitely will have a conduit and electrical cable supply there, so we don't have to worry about sensors or actuators there. But in the case of bins, we can't. I mean, just imagine you have a trash can in a shopping area. It's, let's say, 3 or 4 feet high, and if there's a connectivity of a cable to the sensor, it's going to be a big problem, because somebody basically move it, it may come out, as one of the examples. Data transformation, which means this is one of the problems which I'm also facing on my job. when I get the data from a bin sensor or a pit sensor or a parking sensor, all of them are sending in their own encoding formats. Because currently there is not the actual standard defined for different vendors to use for encoding their data. And because of that, we basically have to do a lot of work on the cloud side to basically refer to data sheets and decode the data according to the data sheet of that company device model. And then we have to consider about the regulatory approvals. What it means is, let's say in Pakistan, we know 2.4 gigahertz and a 5 gigahertz, which is used for Wi-Fi, is open. Anybody can use it, but you still have to get the approval from the PTA, Pakistan Telecommunication Authority. But when we talk about 4G, we talk about 3G, and moving forward 5G, different telco like Zong, Mobilink, Warid, Telenor, all of them, they actually buy the frequency range from the PTA. They pay billions of dollars or millions of dollars to get access for 5 to 10 years. So LoRaWAN, I mean, on another side, it's at 922, 923, 915 megahertz frequency range. So if let's say we refer to PTA documentation, they would probably provide as one of the range which is open, but we still have to get the PTA certification before we turn on that IoT device. So there are actually certain aspects that we have to take care of it. The good way, the best known method or best practice method could be you can actually buy a device from a vendor in a local market which already get approval from a PTA. So you don't have to worry about getting a license for it. I have extracted some of the dashboard from the smart city use case which I have deployed. It's actually in Australia, in Melbourne. There is a city there which they call Monash. I basically work for them, and the use cases that we have to deploy for this project as part of the federal government commitment was to do street lights and smart street lights, which are these blue anchor points that you can see. I'm trying to show here. Then we have different parking sites. Each of the parking sites have roughly 50 to 100 or more parking sensors. And then we have bin sensors here. We have pit sensors here as well. Pit means, when you look at the footpath, sometimes in a commercial area on the footpath, you have some type of sewage system. And if it's not properly taken care, it basically gets clogged, and it basically, in the end, you will get overflow of water coming out from it. So this is one of the important use case for the city council, that they want to know earlier before it get clogged. So we are basically monitoring it. So what I'm showing here is there is a overall landscape of map which shows different cyber physical IoT devices connected. I have taken a couple of analytic aspects of the project just to give an idea. So we have a real-time coverage about the parking data. Generally speaking, we get every 20 seconds, we get the data from the parking infrastructure. And here it's showing what is the occupied ratio from the 700 parking bays and how many of them are vacant. Similarly, this basically shows different areas within this occupied area, the percentage of parking which is being occupied. This graph is showing the monthly percentage about the occupancy of the overall parking space. It gives an idea to the city council. And something interesting that you can see here is this data is from 2020, and this data basically from January to June. You can see in January it was 87%. In February it starts falling down, and further from March onward it was a bit low. And the reason was because during the time we start doing the lockdown in Melbourne, so it drastically dropped. And then again, around June timeframe, June-July timeframe, we get some flexibility and people start using that parking space more. But then after June, we basically get another lockdown, and it actually goes down to lower than 60%. So this actually also gave a very good idea about the utilization of the parking, and it basically gave an idea to the city council about how they can scale their actual assets. Similarly, we have a uh, bin use case, which basically tells about the fillness level as well as the temperature of the trash. The reason we need to get the temperature because sometimes people, when they smoke, they actually throw the, uh, there's a possibility of throwing the cigarette butt, which is already, burning. And there was a couple of incidents happened before, which basically triggered a fire. So we can get some idea from there. Similarly, this is for the pit, showing the fillness level of the sewage at the 49%. And this is basically for the smart light, showing um, the percentage of the LED light turn on based on the ambient light. So from this onward, we can have a just general discussion, and I'll be happy to answer any questions.
Thank you, Usman. I think that's pretty cool. And guys, do you have any question? You can quickly come up with your question instead of writing. We can have few minutes that we can use for questions. So meanwhile, the people are thinking about the questions. I can quickly ask one quick question that is more, you can say, relevant with our industry. What do you see and how do you see Pakistani government and the Pakistan from adapting this IoT? I know there's some work going on already in some areas, even including in agriculture area. But what's your recommendation that which particular areas that we can quickly, if we use IoT, then we can quickly have some good results overall in
Yeah,
Pakistan?
thanks for asking this question. It's a very good question. Basically, as I mentioned, one of the key word was the optimization. So, like in other countries, I've seen um, in agriculture use case where, like in Malaysia, they use the water sensors and they use the soil moisture sensor to optimally detect how much water should be released from the canal to the field. So rather than they open up the whole canal and the whole field will be fully, filled with the water, now they make a decision based on the actual sensing information. As an example, it can tell about, let's say, it's a 30% or 20%, moisture level in the soil. So you can basically release and it will go all the way to 90%. Now, I think these type of use cases we could use in agriculture, especially in Punjab, and we have a problem with the water in also other provinces. So water allocation is one of the problems which is being there for a while. Secondly, uh, uh, I've seen the government initiative also to use IoT devices for um, for agriculture use cases, which was I think mentioned an year or so ago. But what is really happening on the ground, I'm not very well aware of it. Most of the work which is being done is, I think, still in an initial level.
Okay, great. So we have some other questions. First of all, that's from Farhan. How to secure it devices communication being hacked? I think that's what mentioned. You can also reiterate. Are there any implementation via 5G anywhere in the world? That's on the chat.
So,
These questions available.
so yeah, I open up the chat so I can go one by one. So the question that you asked me about the security, there are actually different type of security solutions already available. It goes back to how we practice it. As an example, on the IoT devices, there are IoT devices available with the hardware chips or accelerators. So you can actually enable AES-128, and you can basically transmit the data using encrypted payload. But of course, it will also impact on the battery. So there is a lot of work going on the security aspect to secure end-to-end. As an example, some of the IETF standards also put forward how can we do layer 4 end-to-end security. I believe most of the people would know about TLS, which is primarily used also for SSH, which normally we use for also connecting to our company network. There is another one which is DTLS, and DTLS has been specially designed to provide end-to-end security solution. So mostly IP-based IoT devices, IP main Internet Protocol version 6 based devices are using DTLS. So I'll also go with the question, which is what are the use cases for Zigbee over Bluetooth? Basically, Zigbee and Bluetooth are competing with each other in a current landscape. Previously, Bluetooth was primarily used for, as you know, headsets and wearables, whereas Zigbee was used primarily for sensing and actuating purposes. The current version, the Bluetooth 5 and Bluetooth 5 Plus Plus, there is a Bluetooth mesh or BLE mesh which came out, and it is trying to compete with the Zigbee. And the good thing has happened in the Zigbee Alliance. They actually consolidate the application layer for both Zigbee as a Zigbee and Bluetooth has the physical layer, the data link layer or MAC layer, and then it also has a network layer. So on the application layer point of view, they're trying to do interoperability, which means you could buy a bulb having a Bluetooth LE or BLE, or you could buy a bulb which is having a Zigbee, and you will still be able to, run in your home using a gateway. So, but they are basically designed for different purposes, especially Bluetooth. But Bluetooth is trying to come into the Zigbee landscape, and one of the key reason is, as you know, Bluetooth is available in the phones and in the laptops. It's easy to communicate as compared to Zigbee, which requires a specialized gateway.
So we have few more
So
questions. Sorry to interrupt you, Usman.
sure.
Because we are over time already. So Farhan also asked for 5G implementation and range and device battery. Then we have a question from Salman Nemat, who already raised their hand.
Okay. When we look at the cellular aspect of it, there are a couple of technologies which are going to use for IoT. 5G is there, but based on what we have used in the field, actually it can use very well for a high bandwidth, low latency application, such as you want to use LiDAR, you want to use cameras, is very good. But when we talk about sensors and actuators, we don't get much longer battery life. We basically use it in Melbourne. And generally speaking, with the SIM card based network, the signaling behind the scene actually consume quite a bit of power. So we normally can get 20 to 30 days of battery as compared to LoRaWAN, which basically give us roughly 2 to 3 years of battery time. So still 5G is in the development. 3GPP is working on different aspect of it, but the low power part of it, or the specialized the specialized M2M based the 5G or 4G is still, I think it will take some time, but it will definitely be part of the logistics type of use cases and the supply chain type of use cases, especially when you talk about roaming. Like for example, a truck is going from Malaysia to Thailand, and Thailand to another country. The cellular M2M will be a better application to use for.
Yeah. Okay. Thank you, Usman. So quickly, Salman, can you please share your question?
Hi. Can you hear me?
Yes, I
Yes.
can hear you.
Hi. First of all, thanks for the comprehensive presentation. It was quite insightful.
Sure.
I have one question regarding the current situation. You are being a solution architect. So whenever you design a solution, how much integration effort and how much development effort are required to set up a project? Nowadays, there are a lot of off-the-shelf component, and they can also work seamlessly with a lot of gateways. So, what are the development effort required to set up a solution for like smart city?
Thanks for asking a good question. Actually, it's a very long answer, but I try to make it as short as possible. When we talk about IoT sensors, we are not gonna, I mean, basically, we don't buy components to put on a board, because if you put our own components on the board, let's say you take Raspberry Pi or you buy Arduino shields, those are good for prototyping, but those are not good for actual deployment. So, like when we bought the bin sensor, parking sensor, they are more like actual products. We can we can basically depend on the vendor for making it in a way that, let's say if it doesn't work with the warranty, we can ask them to change. So I mean, one model is if in a certain use case like parking or bins, we have those sensing products we basically buy and we deploy. Other cases is when we don't have it, then uh, we have to actually build it. And in that case, we have different type of options for uh, let's say different type of boards which we could use. Either say it's a real-time operating system or a general purpose operating system. Now the resources varies. Like in my case, I was actually taking care of the IoT side, which means the devices part, anything related to the devices. I was the one who was working on it on the embedded side. Then the configurability of the network, I was working on it. Then I have a team of 7 or 8 people with me. There were people from the city council. There were 3 to 4 people from city council, which were working on the actual fiber optics, deployment, the Wi-Fi deployment, the couple other stuff that where we need to connect to the backend system or backend infrastructure. So they were responsible for the physical infrastructure. I was responsible for digital infrastructure. So I have a couple of people which work with me on the AWS side. I personally work on the edge computing side. Then I got a guy which basically work on the dashboard side, and the mobile app was another guy. Then I got 4 data scientists who basically work on let's say parking data insights, bin data insights, and so on and so forth. So if you ask me, to be honest, it goes back to primarily what does your city council want. I and my team work directly with the city council teams. So there was a team which is responsible for parking. There's a team which is responsible for waste management system. There's a team which is responsible for traffic. So we directly get the requirement for them, and then we use that one as a baseline for us to build our features. As compared to general purpose solution, which mostly the system integrator, they buy it from the China, from the Korea, and they basically just put it there. But we go a little bit differently, because my part of my role was to bring forward research components coming out from the Monash University. So if I go with an approach where I basically buy a solution and put it there, it won't work, because I don't have access to the source code and I don't have access of integrating it. So my time primarily spent on sorting out the IoT side, then work with my team to build the software solution on the AWS itself, and then work on the front end side, the data side of it. And biggest challenge I had was the integration with different vendors. Like the smart lighting was from another vendor. They have their own proprietary APIs. Then there is another use case which is doing their own hardware and software. They have their own proprietary APIs. To pull the data and put it back and integrate into our open platform has taken quite a bit of time.
Okay, I think,
Did I answer your question?
yeah, Salman.
Yes, thank you.
Okay, so we are already over time, and thank you very much, Usman. It's a very, very good and detailed session. And just to announce everyone that we are going to have a 2 days IoT course in Pakistan that will be conducted by Usman just to educate more professionals in our country. Because so far, the services and the education point of view, there's a lot of things where we are lacking. We need to work on. So this is the reason we will be inviting other Pakistanis, overseas Pakistanis, who can contribute to educate our people. So this initiative will be taken starting from this IoT side. We are already working on agile area, but IoT and AI, all other areas are also very important. So Usman, we are privileged to have you on board, and inshallah we'll announce this course very soon. Thank you everyone for joining, and Usman, especially you, for having this session.
Thank you. Just a quick question here, because may I know where are you conducting this training? Is it going to be like Islamabad, Karachi, where? And when do you think it will be expected?
Yeah, that will be online and not in person due to the COVID situation. And the dates will be released soon because we also need to work on for the schedule point of view. Usman is actually working in Australia, but right now he's in Pakistan for some work, for personal reasons. But he will be traveling back to Australia. So we will see all those options and we will publish the dates accordingly.
Thank you. Thank you very much. Thanks for the fruitful session, guys. Thanks a lot.
Thank you.
Thanks for attending. And if you have questions, you can directly communicate with me over the LinkedIn.
Are these presentation will be available? I see that
Sure.
you are also recording it, Mohsin.
Yes, recording will also be available on our YouTube channel. All session recordings are available. So we'll share the link over there.
Okay. Yeah,
Okay.
thank you.
Okay. Thank you, everyone. Have a good day. Thank you. Allah Hafiz.
Thank you. Bye. Allah Hafiz.
Thank
Thank
you,
you very much, everyone.
Hafiz.
Have a good
Thank you.